Good day, my name is Dinesharajan Naidu, and today I will be presenting my problem-based task. To start off, we are going to be configuring VLAN and inter-VLAN, and I'm going to be using S1 as my example. So to first start off, we're going to assign the host name, which is give a name to in the CLI to the device based on the device's name, right? And yeah, next we're going to create and name the VLANs. And as you can see here, we have created VLAN 11. This is how you create the VLAN. And how do you name it? Is you just enter name and then management. Management is the name of VLAN 11. And how do you delete the VLAN? I've included right here. So as you can see here, VLAN 30 is not a VLAN that we want. So we exit out of the VLAN and we put no VLAN 30. All right, next off. And this is the list of VLANs that I referred to configure for each switch in the packet tracer. So for S1, S2, and S3, they are using the same VLANs, but since S1 is connected to the router, it does not have any end devices. It's just an intermediary switch between the router and the two other switches, S2 and S3. I do not need to configure their interfaces, the interface for the VLANs in switch 1. They just need to be present so that they are able to be trunked. And for S4 and S5, there is no native VLAN, so we just need to configure VLAN 51, 52, and 53. And this is the NIDs for each VLAN, as you can see right here. And these are the interfaces for the VLANs. So it's easy to configure. Next, we're going to create the management interface. So for switch 1, the management interface is VLAN 11, as the name itself says, VLAN 11 management. So yeah, we're going to set the IP address for the VLAN, as you can see here, with the subnet mask, and make sure to no shut it so that it's not down. And we need to set the default gateway for the switch. Next, we're going to configure the access ports for each VLAN. And as I said before, S1 does not need to configure the access ports as there are no end devices connected to S1. And this is just an example that I'm giving. And yes, as you can see right here, configure trunking ports. This is between S1 and router. S1 and router are connected to interface G0/1. And we're going to use this to trunk. We're going to set this to trunk so that it allows VLAN 11, 22, 23, 20, 44, and 99. And also we need to set the native VLAN for each trunking port within that same network. And as you can see here, repeat all until all access and trunk ports have been configured for each switch. So S1, S2, S3, and you can repeat this commands for S4 and S5. You just need to change the VLANs and the interfaces. Just make sure to refer to the table as shown just now. And as you can see right here, the trunking ports are these ports right here, these ports, these interfaces right here. And S1 to PUO is trunking so that it is able to communicate between the end devices to the router. And these are all set to access mode, mode access, and they are set to a certain VLAN. So it isolates each VLAN, creating a more secure network. And for S4 and S5, you can do the same exact thing. It's just that you need to make sure the IP, the management VLAN for S4 and S5 is correct, the default gateway is correct, and also you need to check the interfaces that need to be set to access. And next, we're going to configure the sub interface for each VLAN. So yeah, first we need to create the sub interface. So interface G0/1.11. This is for VLAN 11, and assign the sub interface to the VLAN. So this is the command for it, encapsulation.1q11. So for, let's say, native VLAN, which is 99, we set to native 99. That's a special case. And IP address, the IP address of the sub interface. And lastly, we must do no shutdown in the main interface. So for G0/1, yes, that is the main interface. We do no shutdown and no shut each sub interface. And you can repeat the steps for G0/2 for VLANs 51, 52, and 53. Just make sure the IP address is correct, and the VLANs that assign you the sub interface to the correct VLAN. And this is the table that I use to find the IP address for each of the devices in the network. And yes, this is the table that I use to determine the IP address for each end device. And as you can see here for the VLANs, and also the G0/1 VLANs and G0/2 VLANs. And for basically all the devices, the IP address you can refer to here and use the table that I've shown before to find the IP address for each end device or each device. And next, we are going to be performing ether channels. And first, you need to specify what interfaces are included in the port channel. So for port channel 3, we're going to be including 21 F0/21 and 22, and the mode desirable, and this is to identify the port channel. And we're going to enter the port channel interface. This is for a switch. So we're going to enter switch mode trunk, make it to trunk, then put the native VLAN. If there is a native VLAN, you need to set the native VLAN. Since this is an interface between two switches, and switch trunk allowed, so allow certain VLANs to make it more secure and no shutdown. And for next is configuring ether channel in a router. So yeah, as I said, interface range, first you set the range, and then you create the port channel. And then for router, you don't need to set a mode, as the modes are mainly configured in the switch. And the interfaces, port channel 1, you need to set the IP in a router. This is how you set an IP address in a port channel for a router. And this is the table I referred to find the interfaces needed for which port channel and what mode to set to the ether channel. And the ether channels that we are configuring are between S1 and S2, S2 and S3, and S1 and S3, and also S4 to S5, GPK to SWA, and SWA to SWB. Now, why is this orange? Because this is this is because of the STP protocol blocking this port channel so that it does not loop in the network. So the packets do not loop in the network and it does not cause a crash. And lastly, we're just going to set the IP address for each end devices. So for the PCs and the servers. So we just refer to the IP addressing table in the packet tracer for the IP address, and we use our own addressing table to determine the IP address for the end device. And this is the last line, as you can see here, because it's easier to configure everything than setting the IP for the end devices. And how do you set for an end device, an IP for end device? So you just have to open an end device, go to the desktop and IP config and set the IP, default gateway, and subnet mask. And this is the table I use to find the IP address. So you can see here the VLANs. This is for easier reference, and the first usable IP to last usable IP. And next, this helps to determine what IP to set to the device. Next is testing and verification. So testing should be done within each network once you have configured within that network, and use PDUs to test the network. So I've used a PDU, which is letter type of icon, and ping S3 to S1, and it will travel from here to here, and it is successful. So that means it has been configured correctly. If the ping has failed, means it's configured incorrectly. And to find the problem, you need to check the aspects that the user, the technician, has configured. Now, as you can see here, how do we find the problem? What are the commands? So let's see the commands, shall we? And this is why verification comes into play. This is where verification comes into play. And these are some of the commands I use to verify the connections in a router. So show IP route, it verifies the routing table. So what device is connected to what interface to a router in a router, and show IP interface brief is to verify the interfaces of the router, their IP, and whether or not they are manually down or manually up. And show run, I use show run personally to show the configurations that I've done on each interface so that I can identify if I have not done a command or not. And this is an example of a routing table. As you can see here, an IP address is set to an interface, and it's very easy to track the IP address. You just have to refer back to your table. And the interfaces of a router, as you can see here, I've set the correct IP address for G0/1.11, and you can see it's up. And these are some of the commands that I use to verify configurations on a switch. So show Vlan Brief, the first one, is to verify the list of VLANs configured and also the interfaces configured to the VLAN. And show IP interface brief is to verify the interfaces of the switch, whether or not they are down or up, and also their IP address, and also the IP address for the management VLAN and whether or not the management VLAN is down. Show interface trunk is to verify trunking ports and VLANs allowed on the ports, and also the native VLAN, whether or not it has been configured. And number 4 is show ether channel summary to verify ether channels and ports in those ether channels. And lastly, show run I use to verify the configurations for each interface and check the default gateway of a switch. And these are some of the examples of in verifications. So for show VLAN brief, as I've said before, to check the VLANs, and as you can see here, the VLANs have been created, but the interfaces have not been set to the VLAN. And these are all the VLANs that are allowed on trunk and also in the management domain and in the spanning tree. And as you can see here, the native VLAN has been set to each port. And lastly, once everything has been configured correctly, once you have test verified, you can see that each end device is able to ping to the DNS server. That's the purpose of this PBT, problem-based task. Thank you so much for watching. I hope you had a great day, and I hope I'm able to help with this problem-based task. Thank you so much for watching.